linking files. Linking files is a great option in the Linux file system. If you need to maintain 2 or more copies of the same file on the system, instead of having a separate physical copies, you can use one physical copy and multiple virtual copies called links. Actually, yeah, links here like this. Let me actually open our Gromit and write it right down here. Yeah, here, links. Oops. So, a link is a placeholder in a directory that points to real location of file. So there's a two type of links here. So let's actually make it circle, and the first type is a symbolic link. Here, symbolic. And the second type is hard link. So a symbolic link is a simply a physical file that points to another file somewhere in the virtual directory structure. So that's two symbolically linked together files do not share the same contents. So to create a symbolic link to a file, the original file must pre-exist. So you can then use the ln command with the s option to create a symbolic link here. So ls here, for example, let's write our file, and here open our file manager, open folder, and for example, let's create a test file, write something in it here, and so we have some 531 bytes in it that we will write it here. So we will do lsl here, test file, and here, as you can see here, we have bytes and the test file here, and as you can see, we have seen our permissions here. So in order to do that, we will use ln s, and for example, we will do it the test file. Firstly, we will pass our file, real file, and then we will sl here, test file. Or you can, yeah, you can also use that like that. Yeah, they don't have to share the same name or same name structure. So in this example here, let's actually lsl, and here in this example, notice that the name of the symbolic link sl data file test file is listed second in the ln command, as you can see here. So the symbol here, actually let me, and as you can see, this is the symbol here, this symbol here displayed after the symbolic link files long listing shows that it is symbolically linked to the file test file, as you can see here. So also I want to note that the symbolic link file size versus the data file size. So the symbolic link SL file size here is only 9 bytes, where our data file has, 531 bytes in it. So this is because our SL test file is only pointing to our test file, so it actually doesn't contain any contents in it. So they do not share contents, and they are physically two separate files in our directory file system, but our SL file is only purpose to show that where our test file is. So another way to tell these linked files are separate physical files is by viewing their inode number. So the inode number of a file directory is a unique identification number that the kernel assigns to each object in the file system. So to view a file or a directory's inode number, you can simply use the e parameter here. Actually, it's clear. And you can simply use e parameter right here, and then after that we will pass our test file. And as you can see, this is our inode number for our test file, and let's actually in here, and the oops, not like this. That's clear test file, and then we will do oops, not like this. Yeah, SL test file, we're gonna write it right here. So test file, and here we will do SL test file. And as you can see here, there are two different inode numbers. So remember that inode numbers are only assigned once in every file here. So cannot be two inode files for now, but you will learn about inode numbers in next lectures. So another way to tell here that we can also, yeah, this example showed us that the file inode number, our data file inode number is 9, our data file inode number is 3932329, while our SL test file is 3932659, as you can see here. So a hard link creates a separate virtual file. So actually they are the different files, right? We got it. Yeah, they are the different files to hold different files. But the hard link creates a separate virtual file that contains information about the original file and where to locate it. However, they are physically the same file. So when you reference the hard link file, it is just as if you are referencing the original file. So to create a hard link, again, the original file must pre-exist. In this case, our original file is my test file. Except that this time, there's no parameter is needed on the ln command. In order to do that, we're gonna create ln. So actually, we learned about the symbolic line here. So we learned about symbolic. Now we're gonna learn about the hard link lines. So now we're gonna write ln my test file, and after that, we're gonna use the hard link. So in this case, SL that we mentioned, that SL is a symbolic, and in this case, let's actually write hard link to notify us that this is the hard link file, or another users that notify us that this is a hard link file and not symbolic file, symbolic link. So in this case, let's actually test file. And here we created our hard link file, clear lsla, oops, lsl, yeah, here. And let's find where, yeah, as you can see here, this is test file, hard link file. So in this example, actually, we need also create, let's actually create the, first this, yeah, let's actually ls, and I will explain all of this here. LE here, and we will make it what was our hard link file here in this case is HL test file, and ls LE here code oops, no, not code here, test file, and here as you can see 0 bytes. And now let's actually use our my test file. Yeah, actually I forgot what we are working with. Yeah, it has to be test file. Yeah, test file. In previously we actually created wrong file name. We need to create a test file here, so we will delete it. And as you can see, I want to show how hard link files look like. And as you can see, SL has a tick like this in the UI graphical interface, but HL doesn't have any ticks, and here as you can see here it's empty because we created from the empty file. Actually my test file is empty, as you can see here. So let's also delete this here. Yeah, now we're gonna use the test file, which is we've written some contents in it here, and now we're gonna use the lsle here. No, firstly we're gonna create the ln or my test file, or test file, and after that hl my or test file. Right, just a test file. Create a hard link. This because the test file hard link exists. Actually, let's test file my text file here, my test file, and we created our hard link. And now we're gonna also show our hard link file here. So LA here. So in this case, we're gonna use the test file, and here, as you can see, we got another example. So in this example, we use the lsle command to show both the inode numbers and the long listing numbers for the code files. Actually, let's also show, I want to show you how our inode number looks of our hardlink file, in this case my test file. And here, as you can see here, these inode numbers are the same. So these both files, which are hard linked together, share the same inode number. This is because they are physically the same file, and as you can see, these all of them are the same size. This is because they are physically the same file. And here we have two links. In addition, their file size is exactly the same as well. So be careful when copying the linked files. If you are use the cp command. Actually, let's take it. Yeah, if you use the cp command to copy a file that's linked to another source file, all you are doing is making another copy of the source file. So this can quickly get confusing. Instead of copying a linked file, you can create another link to the original file, and you can have many links to the same file with no problems. However, you also don't want to create a soft links to the other soft linked files. So this creates a chain of links that can be confusing and easily broken, causing all sorts of problems. So you may find symbolic and hard link difficult concepts. Fortunately, renaming files in the next lecture is a great deal easier to understand that. So I'm waiting you in next lecture.